In this lesson, we are going to review simplifying radicals. So let's begin. So when I ask you to simplify a radical, what I'm asking you to do is break it down so that there are no perfect squares inside the radical. So here's how we can do this. Let's take a look at the square root of 45. Well, when we simplify radicals, we are going to go ahead and break them down by a factor tree. So what is the smallest number that goes into 45? Well, 2 does not go into it evenly, so my next number would be 3. Well, I know that 3 times 15 is 45. Now, I'm not going to mess with that 3 because the only way I can break down 3 is to 1 and 3. So if it's only multiplied by 1 in itself, we're going to stop there. So really, it's kind of getting it to prime numbers. So for the 15, well, I can break that down into 3 and 5. I can't break down 3 and I can't break down 5. So once I've broken them down into all prime numbers, I look at what I'm left with. So I have a 3, and a 5. Well, if you have any numbers that are the same, you're looking for groups of 2. And I have a group right here, 3 and 3. I'm going to go ahead and multiply those together. So 3 times 3 is 9, and I'm still going to write it inside the square root because all of it started inside a square root. Now, this 5 does not have a partner, which means it's still in a square root, but it stays by itself, the square root of 5. So you can check yourself. When you rewrite it, when you take 9 times 5, you should get 45, and we do. Well, this is nice because 9 is a perfect square. The square root of 9 is 3. 5 is not a perfect square, so it stays inside the square root, and my answer is 3 square roots of 5. So let's take a look at another one. If I wanted to do the square root of 90, well, what goes into 90? 2 would be the first one. So I can go 2 and 45. I can break down 45 into 3 and 15. 15 into 3 and 5. And now I have all prime numbers at the end, so I'm going to stop. I'm going to look for groups of 2. So here's a group of 2. And 3 times 3 is 9, so it's going to be the square root of 9. And then I have this 2 left over and this 5 left over. Well, they don't have partners. So I have the square root of 2 and I have the square root of 5. So let's simplify. Well, 9 is a perfect square and the square root of 9 is 3. So since it's a perfect square, it no longer has that radical. 2 is not a perfect square, and 5 is not a perfect square. So since I can't simplify those, I can go ahead and multiply them together at the end. So 2 times 5 is the square root of 10, and it has the radical there because neither of them were perfect squares. So my answer was 3 square roots of 10. All right, I want you to try the square root of 116. Pause the video, and when you have it done, come on back. We'll see how you did. Welcome back. So let's look at breaking down the square root of 116. So when I go ahead and I do my factor tree, I know 2, and hopefully you're getting 58, because 2 times 58 is 116. I can break 58 down into 2 and 26. I can break 26 down, actually, not 26. 2 goes into 5 2 times with 29. There we go. So 2 and 29. Now, 29 is a prime number. Nothing goes into it but 1 in itself. So I've broken it down as much as I can. I look for groups of 2. So there's a group of 2. And then this 29 doesn't have a partner. So 2 times 2 is the square root of 4, and then I have the square root of 29. Well, the square root of 4 is 2. I can't take the square root of 29, so it stays in the radical since it's not a perfect square, and my answer is 2 square roots of 29. So there you go. That is how we simplify radicals.